Once we get used to thinking about those numbers and comparing them to halves, whole numbers, our closest whole number, then we also have to be able to take a look at these decimals and fractions and be able to determine which is the largest, which is the smallest. When we do that, we need to make sure that we are comparing the same thing. So I'm going to change all these numbers, or think of these numbers as fractions of 10. I know that 7/10, 4/10, 1 3/10 is the same as 13/10 if I were to color that in on a grid. Which is largest? 13/10. Which is smallest? 4/10. In the middle, 7/10. If I were to take a look at these two grids, I know that this grid is showing me 90 hundredths. I can write it as a fraction. I know that that is the same thing as writing it as a decimal. There's 90. If I look at this grid, I see that it is divided into tenths and that it is showing me 9/10. I can write that as a decimal. It is the same thing. And when I compare these two, I see that they are exactly the same. 90 hundredths is the same as 90 hundredths, is the same as 9/10, is the same as 9/10. They are all equal. If I were to compare these numbers as decimals, I know that this says 48 hundredths, this is 5/10. Well, I know 5/10 is the same as 50 hundredths. Therefore, 5/10 is larger than 48 hundredths. 71 hundredths, 6/10. I know that 6/10 is the same as 60 hundredths. Therefore, I know that 71 hundredths is more than 6 hundredths. I can look at which one has more tenths, but I can also look at which ones has more hundreds. I think hundreds, yeah. 90 is bigger than 73. 90 hundredths is bigger than 73 hundredths. Oops. 2/10 is bigger than 17 hundredths. If I take a look at this grid, this hundreds block, hundreds grid, how many of the squares are shaded? Well, how many are shaded? Well, 10, 20, 30, 40, 50. I know there's 50 out of 100. I know that that's the same as decimal 50. I know that's the same as 5/10. I know that's the same as decimal 5. And when I look at it, I know that that's all the same as 1/2. Half of that block is shaded. All those numbers represent 1/2. I can take a look at this hundreds grid block again, and it says which fraction of each block is shaded. Well, taking a look at this one, I can see that there's 10, 20 hundredths. I can see that there's 1, 2/10. I can see that's also the way of saying there are 2/10. But I also notice when I look at the red lines, they've divided it into 1, 2, 3, 4, 5 pieces. One of them is shaded. I know that's the same as 1/5. Oh, 20 hundredths, same as 2/10, same as 1/5. Let's take a look at this block. Oh, I can see that there's 5, 10, 15, 20, 25 hundredths are shaded. Can I make tenths out of that? Well, if I took this one down and moved to 10, nope, I have 5. I can't make tenths out of that. But I notice when I look at the red lines, it's divided into 4 pieces. And one of those 4 pieces is shaded in. I know that 25 hundredths is equal to 1/4, or we can say 1/4. They are the same thing. So if I'm comparing my fractions and decimals, and I'm trying to determine the largest number, 1/2 or 57 hundredths. Well, if I go back and think about that 1/2, oh, it was 50 hundredths. Therefore, 1/2 is the same as 50 hundredths. Oops, messy writing. Or 57 hundredths, which is larger? Well, 57 hundredths is larger than 50 hundredths. What about 1/4 or 23 hundredths? Well, when I think about that 1/4, I know that 1/4 was the same as 25 hundredths. So if 1/4 is the same as 25 hundredths, which is larger, 1/4 or 23 hundredths? 1/4 is larger.